Hi, I'm Alexander Ryazanov. I'm the Chief Technical Officer of IPSNIP Computing. In this short video, I'm going to demonstrate how our query tool Hydra can be used to formulate a federated query across several data sources, including the US government website on clinical trials. We want to answer the following question. We know a bacterial name, for example, salmonella enterica cerovar typhi, and we want to know what drugs have been tried for infections caused by this bacteria. What you see here is the main menu of the Hydra query composition GUI. And I'm starting to compose a new query that will find names of drugs studied by clinical trials for salmonella enterica infections. I'm entering the title for the new query. Names of drugs studied by clinical trials targeting infections caused by salmonella enterica cerovar typhi. The first part of the query will be describing a bacteria species, so I'm entering species. Another key phrase has name. The graph is okay, but let's see if we can improve it. This one is more detailed, so I pin all the nodes. The name must be similar to salmonella enterica cerovar typhi, so I'm typing similar to. This graph is okay. This node will represent the string salmonella enterica cerovar typhi, so I'm adding the auxiliary predicate represents value. And now the string itself. Salmonella enterica cerovar typhi. Now I'm going to link the bacteria species to the types of diseases caused by it. The keyword is disease. Let's choose the right graph from what the system suggests. This one seems good. Species causes disease type. We'll need the name of the disease type represented by this node. So I'm typing has name. Represents value again, just to get access to the name string. And this will be a variable. And we will actually show it in the query answers. We will need to search for diseases with similar names in clinical trials. So I am attaching the predicate is similar to. And another predicate has name in the reverse direction. Obviously this will be a disease, and we want it to be the target of a clinical trial. So we are using targets also in those direction. Clinical trial. Let's see how we can attach a drug now to the trial. Predicate studies must be okay. So what we have is clinical trial, studies, and this will be drug treatment. And drug treatment presumably uses a drug. You need a name for the drug. So it has name. As usual, we request the specific value, represents value. So drug has name, something that represents a specific string value. And this will be a query variable, drug name. I will use this button to compactify the query graph. So as you can see, all the auxiliary represents value predicates were hidden. Before I test the query, I want to show briefly the study services available for query execution. So I go to the registry. This is just a list of services representing multiple bioinformatics data sources. They are essentially our virtual database that we can query with Hydra. For example, this get clinical trials by target disease name service is likely to be useful for our query. Also, this get names of drugs studied by clinical trial may help to extract drug names from clinical trial web pages. Let me now run the query in this Execute tab. It takes a few seconds. You can see that Hydra is now finding some answers. Some disease names here and a few drug names. Some of them are placebos because the corresponding service does not filter them out. Finally, we can save the results in an Excel spreadsheet for convenience. And here is the generated spreadsheet. And this concludes my demo. Thank you.